Hello and good day everyone. In the last video, I've shown you an example of how to add two floating point numbers if they have the same exponent. And we have seen that adding two floating point numbers is not much different from adding two fixed point numbers, especially if they have the same exponent because we just simply add the mantissa. In this video, I'm going to show an example on how to add two floating point numbers if they have different exponents. Remember, this is our process before, no? If the two numbers have the same mantisas, or rather exponents, we just add the mantisas. If not, we focus on the smaller mantisa. We will float the binary point to the left by shifting to the right. And during each time that we float the binary point, we increment the exponent by 1. We repeat this until the second exponent, or rather the small exponent, equals the bigger exponent, no? When the two exponents are already equal, we just simply add the mantisas. Now, when an overflow occurs at the most significant bit after the addition, the binary point is floated to the left by shifting the bits to the right again, and the exponent is incremented by 1. Let us proceed to an example. We have the same mantisas in the previous example, but this time we have two different exponents. First exponent is 6, being 00110, which is equivalent to a decimal value of 6. The second exponent is 01000, which is 8. So between 6 and 8, there's a difference of 2. So what we will do to the smaller exponent is adjust the mantissa to the right, okay, so that its exponent will be the same as the bigger exponent. So in this case, we have to adjust it to the right twice, or we right shift 2 times, so that 6 becomes 8, because the first shifting will make it 7 and the second shifting will make it 8. So what we will do is uh, copy the first 8 numbers, okay, and then introduce. Let's do that. No? This is the original mantisa. What we'll do is introduce the two zeros to the left and remove the trailing bits, whatever they are. Also two positions. So we are discarding values. By shifting the mantissa to the right, we are now having an exponent of 8. So now they have the same exponent, so we can perform the normal process of adding the mantisas. And before we do that, I have converted this to decimal, and the first number is actually equivalent to 35.5. The second number is 225. So we will expect a sum of 260.5. So let us now convert the mantisas individually by copying our binary table. Okay. We still have the same binary table. I copy it and go over to my solution sheet where I paste the values. And the first number is, yeah, it's now the first number. I plug this into the table. Okay, I plug this into the table starting at the binary point. Here is the first binary point of 0.5. Okay, so I'll copy the values 0, 0, 1, followed by 3 zeros, 1, 2, 3, followed by 3 ones, followed by a 0. Okay, that's the 10 bits. Now we know that this now has an exponent of 8. So what is the actual value? Let us compute it by first determining using the exponent, which is 8. And we are going to compute 2 to the 8. Okay, and we will multiply this to the mantissa. So we'll use a formula equals to exponent. That's the exponent sign. The hot sign is the exponent sign. 8. So we have 256, and the decimal value is equals 2 to the 8 times our mantissa. Remember, this is our mantissa. This is the decimal value. So we have 35.5. Now let us convert the second number. Proceed to converting the second number. Okay. So we know the second number to be this. We'll copy this. Okay. And then we'll head over to our binary table again and copy this and put it in our solutions table, the normal way we did it. Okay. And what we will do is plug in the value. I hope you see that. No? We'll plug in this value. Okay. Starting at the zero point 0.5 position. Okay. So we have 3 ones followed by 4 zeros, followed by a single one, followed by 2 zeros. Okay. So we now have the mantissa of the second number. We will copy this because we'll have the same exponent. Okay. So this will be equal to this times the new mantissa. Says remember the mantissa. So we have 225. Is that correct? Let me check. Yes, 225. So now since the two numbers have the same exponent, we will now add the two mantissas together. Okay. By copying the first mantissa and the second mantissa. Copy the first mantissa. This is the first mantissa. Then we'll also copy the second mantissa, which is this. This is our second. So since we know that they have the same exponent, okay, being 8, we can now add the bits one by one. We start with the least significant bit. So we have here 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 1 is a 0 with a carry of 1. 1 plus 1 plus 0 is another 0 with a carry of 1. And 1 plus 0 is 1. Okay, we have 0 plus 0, which is 1. We'll have another 0, rather 0. No? We have another 0 plus 0 is 0. And we will have a 1 plus 1, which is a 0 carry 1. 1 plus 0 plus 1 is another 0 with another carry. 1 plus 0 plus 1 is a 0 with a carry of 1. So rather 1. We'll have 1 here. And we will copy the decimal. Now take note that we have the result has an overflow of 1. What we will do is we will adjust our result so that there will be no overflow. So we'll move this over to the right till the last. No? We move this over to the right 1 bit position. Right? So we have moved the mantissa 1 position to the right. We have done a right shift once. Okay. So we have done this right shift, and then in the vacant position we will now put the 1. Okay. So now we have the result. Okay. So our new exponent is now 9. It was previously 8, but since we have shifted, our new exponent is now 9. So this will be a 0, 1, 0, 0, 1. Okay, that's 9. How many bits is our exponent? 4 bits, yes. Our 4-bit exponent is now 0, 0, 1, 0, 0, 1. And our mantissa will be the concatenation, no? Concatenate. This. We don't have to specify the binary point. because we know that this is already the binary. Okay, so this is our new sum, no? 0, 1, 0, 0, 1, and with the following mantissa. Now, how can we correct this? How can we check if this is correct? Okay, we'll plug this into our binary table again. We'll copy it from shift 1, or rather sheet 1, and then plug this in. This is our final result. Okay, so we'll just plug in the mantissa. We have how many zeros? 1, 2, 3, 4, 5. We have 1 followed by 5 zeros, 0, 0, 0, 0, 0, followed by a 1, followed by 2 zeros. Okay, so this is our new mantissa. Now, what's our, we'll copy this again because we will need to convert the actual value. Okay, now in this step, we are just checking the answer. Our exponent is now 9. And this is 2 to the 9. Okay, then we'll just multiply 2 to the 9 with our new mantissa, which is this. Okay, 260.5. This is the mantissa of the sum. 260.5. Now, did we get the right answer? Yes, the expected answer is 260.5. So I hope you follow, no? If not, I will just upload this to our regular site and then you review this video again. So what we did in review was adjust, okay, the exponent of the smaller exponent by shifting the mantissa to the right or floating the binary point to the left. They have the same thing. We have to do that twice because the original exponent is 6. So we want it to be 8 because the second number has an exponent of 8. When they have the same exponent, we added them together. And when we added them together, we had an overflow of 1, the most significant bit. So we right shifted again. Okay. And since we right shifted or floated to the left, we are going to increment the exponent by 1. So the exponent is now 9 from 8. And the actual decimal value is 2 to the 9 times the mantissa of the sum, and we found it to be 260.5. I hope you follow. No? In the next video, I'm going to show you how to represent negative numbers in binary. Thanks for watching and see you in the next video.